back to Spring Into Math It. Today's lesson is solving linear equations by elimination. A 2x2 system of linear equations can be solved algebraically by using the elimination method. To use this method, you must write an equivalent system of equations such that when two equations are added or subtracted, that one set of variables is eliminated. Let's take a look at what that means. Here's an example. Here are two equations. 3y equals 2x minus 5 and 2x equals 2x equals y plus 3. If we rewrite them, we can actually start to use the elimination method. I now have negative 2x plus 3y equals negative 5 and 2x minus y equals 3. You can see here that we have a negative 2x right on top of a positive 2x. If I add those two things together, those variables will be eliminated and we could solve for y. Let's go ahead and do that. So we've gone ahead and eliminated the 2x and the negative 2x because when you add them together you get 0. This results in an equation of 2y equals negative 2. Now we can go ahead and solve this simple one-step equation to get our value for y. All we need to do is divide by 2 on both sides of our equation. And when we do that, we get y equals negative 1. Now hold on to that negative 1 because we're going to use it here in a moment. So again, we just learned that the new value of y in this system of equations is negative 1. Now you can insert this value into the original equation and get your new x value. So here we have 2x minus y equals 3. For y, we're substituting the value of negative 1, and now we can solve for x. 2x minus 1 equals 5. That minus and minus, when multiplied together, result in a positive 1. So now we have 2x plus 1 equals 5. Again, all variables need to be on one side of the equal sign, and all numbers need to be on the other, so we need to move that positive 1 to the right side of our equation. And because it's positive, we must do the opposite, so we need to subtract 1 from both sides. Now when we do this, we get 2x equals 2. And we can go ahead and simplify and reduce by dividing both sides by the number 2, and in this case, that results in the value of x being 1. Now, the solution of this set of equations, 3y equals 2x minus 5, and 2x equals y plus 3, has a very specific location on that coordinate plane where they cross. That is the answer. And in this case, it's 1, negative 1. Here's a second example. We have 6x minus 7y equals 8, and 15x minus 14y equals 21. Now we need to do something to the first equation to help use the elimination method or elimination process. So scaling the first equation or multiplying the whole thing by negative 2 will allow us to use the elimination method. So when I multiply that entire equation, each individual part by negative 2, it results in negative 12x plus 14y equals negative 16. So now we stacked our equations, and we have a positive 14y and a negative 14y. When we add those two equations together, those go away, and we can solve for variable x. So when I do this, negative 12x plus 15x results in a positive 3x. The 14y's disappear, and negative 16 plus 21 is a positive 5. So I have 3x equals 5. We divide both sides by that 3 to get rid of that 3 in front of the x, and my x value is now 5 over 3, or the fraction 5 over 3. So insert this value into the original equation, and we could solve for y. I've gone ahead and inserted it, and it would look like this. 6 times 5 over 3 minus 7y equals 8. Now when I multiply 6 times 5 over 3, I actually get a nice whole number, 10. So now it reads 10 minus 7y equals negative 8. We subtract 7y, we subtract 10 from both sides, resulting in negative 7y equals negative 2. And we divide by that negative 7 on both sides of our equation, and it results in y equals 2 over 7. So the solution to this set of systems of equations is as follows. 5 over 3, 2 over 7. That's the precise location that those two systems cross each other on a coordinate plane. That's it for today. Catch you next time.